So this is the second video in a little sequence of them, revising AS Further Maths matrices work in preparation for looking at for more work for the A2 content on matrices. And having looked at multiplying two matrices together in the previous one, in this one I want to have a look at the determinant of a matrix, and we'll probably have a look in this one as well at finding an inverse for a matrix. So we're going to be concerned with finding the determinant of a square matrix in particular. The determinant is a number. It's once you calculated it, what the result of calculating a determinant is just getting a number, single scalar value, and each square matrix will have its own determinant, which is this value that's associated in various ways with the matrix that it came from. It's important for us to be able to do this in order to find inverses, which is where we're going with it in a little while. But also it tells us various other things, such as, for example, if the matrix was one that represents a transformation, then the determinant tells us about scale factors involved in the transformation as well. So they crop up in a variety of places. Those are going to be our two essential purposes for finding a determinant. So we're going to be looking at a 2x2 matrix and finding the determinant. In the A2 content, just as a kind of a look ahead, we're going to be looking at determinants of 3x3 matrices, but for now let's just stick with a 2x2 determinant, and a bit of a word about notation. So if I've got a matrix M, there, and I want to work out its determinant. Let's say the M is the matrix with entries. So I'm just thinking about 2x2 matrices. So actually, perhaps I should put that in the title there as well. 2x2 only. Supposing I've got values, 4 values here, A, B, C, D, whatever numbers those would be in this matrix M. Then the determinant, I might use a variety of different types of notation for the talking about the determinant of M. And it's important that you're familiar with all the different possible types of notation. I might refer to it, so in words, in spoken words, I would say determinant of M, but I might write det M like that, or I might write M with two straight lines on either side. That's called a modulus sign. I can't remember if I've used the word modulus sign. I think I might have done. But the modulus symbol around the M representing the matrix, so the modulus sign indicates that we're just looking at the determinant of that matrix. Or I might use that a kind of delta symbol. That's the capital Greek letter delta, which you'll be familiar with from probably physics. Most likely they talk about change of something as being a delta of something. So delta M, that's sometimes occasionally used for the determinant. Or I might just put the modulus signs around the matrix rather than the curved brackets around it. I might just put the modulus sign around the 4 elements within the matrix as well. So a variety of different types of notation, unfortunately, for the determinant of a matrix, and important that you can recognize any of those and be confident in knowing what it refers to. So then the calculation of the matrix of the determinant of the matrix, I take that matrix that I've got there, A, B, C, D there, and in order to calculate the determinant, all I do is A times D minus B times C. Okay, so for example, if I've got a matrix A which is 6, 5, 1, 2, and I want to find the determinant of A, all I need to do is 6 times 2, take away 5 times 1. 12 take away 5 gives me 7. So this has a determinant. This matrix has a determinant of 7. Again, obviously, that's something that you will be able to do from your calculator. But again, as with multiplying two matrices together, it's important to be able to do that by hand. You may well have to do this algebraically. So important to know how the process works, as well as being able to do it on your calculator. And again, it's important to be able to do it on the calculator for checking, for accuracy, for speed, for all of those kind of things. But you do need to be able to do it by hand. And then two alternatives. One important thing is that we sometimes get 0. So, for example, in the case where, well, if it was 2, 4, 1, 2 or something like that in my 2 by 2 matrix, then I would have 2 times 2 take away 4 times 1, give me 0. And this is a significant result, getting a 0 determinant, and an important thing to recognize and remember about. If M has a 0 determinant, so if M has det M being equal to 0, then we say that M is a singular matrix. And that's significant in a variety of different ways, which we'll come to as we come across them. And obviously, if it's not equal to 0, then we call it non-singular. And you may well remember that you probably came across questions that had, something like algebraic expressions in at least some of the positions in the matrix, and you were asked, it's very common to be asked what the possible values of the letters are in order for it to be a singular matrix or something like that. So that's something that comes up quite a lot. Important to recognize the business about being singular. That can have significance for us. So then, having calculated the determinant, one of the things that this is particularly useful for is that we sometimes need to find the inverse. Actually, yes, I think I will put this on a separate video. Actually, we'll do inverses as a separate thing. So I'm going to stop this video there, and then in the next one we'll have a look at finding an inverse matrix.